Hello guys, welcome to HNJ Online Academy, and today I want to take you through ARA, and this is an introduction to ARA. Okay, so ARA is a system for statistical computations and graphics, and this is what ARA is, and again this is ARA. So ARA is a programming language and software environment for statistical computing. That's another definition. And you might wonder why ARA. ARA is an open source. That means it is open for everyone. You don't need to pay a certain amount of fee as with other statistical computing softwares which require thousands of dollars per year. And ARA is excellent for statistical computing and analysis. It just excels in this field. And ARA is a highly active community. What it means is there are a lot of users all over the world that can help you, support you whenever you have a challenge. Okay, so let's get to understand how to set up ARA. So that's how to install ARA. So you get to any browser of your choice, then you just type araproject.org and you click on Crane or download, and obviously it takes you to this other page, and you click on OCloud, that link that is over there, and it takes you to this window. So when you are at this window, you need to decide which operating system you are using. In my case, I'm working with Windows, and the steps that follows after, they are the same despite the operating system. Okay, so you click on base and you click on download. So this is the version that I'm downloading, and when you download, it starts to download automatically. When you click that link, and it takes you to the installation processes. The steps, they are just simple. You need to follow them, simple instructions, and we cannot spend more time on that. Let's get to other things. All right, so get the files that are on the description. These are the files that we are working with throughout this tutorial. They can help you and follow up as we are illustrating. All right, thank you. So let's jump into ARA and let's get to understand. Open ARA, you're going to see this window, and this window shows by default it gives just give a description of the version that you have currently in your machine, and there are these few options that are there, and the rest you need to do some commanding, just typing commands. So I just want you to have an appreciation of ARA first, then we get into other things as we go. All right, so let me just say in ARA now, in any operating system, in any statistical software, we cannot say anything, or we cannot say much without talking about data, without loading data. Then we start the operations. So I'm going to start by saying library dataset. So what I'm doing here is I'm calling for datasets that are in ARA. So ARA by default has datasets that are already installed or are already come with ARA. So in order for me to access them, I need to call this function or this package called datasets. So I call it by saying library. So now it's available, and I can call any data that I want, that I know it is in ARA. Okay, so I'm going to start by iris. So iris is a dataset that is in ARA. It comes with ARA. So it just shows the sepal length, sepal width of different species. Okay, so when we have this data, it doesn't make sense when it is this long. You need just to get a summary of what this data is. So you say summary, then you say iris. So what I'm doing here, I just want to learn, or just want to know what this data is. Okay, so now it shows me that for each variable I have a minimum of this value and max and mean, median, so it just makes me understand what I'm doing or what this data is. All right, so I can also say plot just to get some graphs. Iris. All right, so I have this plot and it shows a very long plot, different types of plots, so that I can familiarize myself with what I'm dealing with. Okay, so I can also do plots for specific variables. I can say plot, then I can say iris, then I can say which one I want, sepal, so I want petal length, and I also want petal width. So mind you, why I'm putting these dollar signs, I'm trying to say R doesn't recognize petal length or petal width by default, but I have to tell R that the petal width that I want is in iris, so that R knows what I want and what I'm talking about. Okay, so it should bring me a graph. I think it's over here. Okay, so this is just an illustration of how to give a quick plot. So obviously it's making sense as petal length increases, petal width also increases. Yeah, that's how it is. All right, so this is just a basic understanding of what really ARA is. We are going to get into depth with ARA soon. So let's move to another section. Okay, so the next step on setting up is ARA Studio. ARA Studio is now more organized. It's another form of ARA which is more organized, and you can see there are now 5 windows over here, and there are 4 windows over here, and which makes ARA organized. The graphs are placed aside, and you have the source where you can put your commands or your scripts. You can write your script there. You have the console where you can run your commands, and also this other window which is packages, plots, and the environment. So you see, this is now more organized than just the plain ARA. Okay, so the idea is now to make making ARA easy. So when you open ARA Studio, you're going to see this source window, and this is where we write our script. If you want to analyze do your analysis maybe later on, you can write your commands over here, and you can save them and you can work on them later. So that's the importance of source. Or maybe you can open a script and start running the commands. That's the importance of the source. And this is the console where you can write your commands directly in this field. Okay, so I'm just going to work with the source here, then I run my commands. So now that I have coded the library datasets, I'm saying I have the dataset available already. I have code for them, I have loaded them in ARA, I've made them available. So I'm just going to call any dataset like we have done and previously, but now let me work with a dataset called mtcars, this one. Then I want to open it, so this is the source. So for me to run this command in a source, I need to press Ctrl and Enter. So now, as you can see, let me just zoom on that. As you can see, my data is now here. I've opened the mtcars. So this is the mtcars. It is these variables. Okay, so I can also simplify this to improve the way we see this data. I can say view, then view mtcars. Okay, so then I press Ctrl and Enter. So it opens this data in form of a spreadsheet, and you can now see more better than what we have done before. So it's now clear. You can rank, you can change whatever you want here. It's more of a spreadsheet. Okay, so that's it with us checking data. And now let's continue with our analysis. I can also do a summary of this data. So I can say summary, then I say empty cars. I want to see what the variables that are there and what, just a summary of the variables that are available. Okay, so that's it with that's it with understanding or introduction to R Studio. All right, so let's move on to another section. Okay, so now we need to talk about packages in R. So what are really packages? Packages are extensions to R statistical programming language. What it means is there are some functions that you can't run in R without a certain package. So you need to have certain package for you to do certain things. So that's what really R is in terms of packages. But we have different types of packages. In fact, we have two types of packages. We have the base. This is installed with R but not loaded. For example, the datasets. It is installed in R already, but when you want to use it, you need to load it. That's why we need the library function. Then we call for it and we make it available. So that's the base package. And we also have the code repeated package. This need to be downloaded, installed, and loaded separately. It doesn't come with R by default. You need to download it and install it and load it. Okay, so this is an example of the packages that we have with different functions. All right, so we have one package that loads them all. That is the Pacman, which is the package management tool. It helps you when you want to install a certain package or certain packages, probably 4 of them. You don't need to load them separately. You can just run this command Pacman, then you list the packages that needs to be loaded. We are going to illustrate on that. So you can make use of the packages.r file that is in the description. All right, so let's jump into R and let's try to understand how to deal with packages, how to install packages in R. So let's open R. All right, for packages. So like we have said, we are going to work with a package called Pacman. So we are going to install it. I'm going to say install. That's the command, install.packages. Install.packages. Then I write the package that I want to be available. So before I do anything, I need to install Pacman. So you need to use this Pacman. Then to run this command, Control Enter. Right, so it's now installing Pacman. And make sure you are downloaded. Yes. Make sure you are connected to the internet as you want to load this package. So as you can see now, it's now available on my packages that I have, but it's not ticked. That means it's not loaded. So for me to load it, I'm going to say library, then Pacman, then Control Enter. Okay, so Pacman is now loaded, as you can see with this tick. All right, so I now need to install other packages. I just need to install a number of packages. So to install using Pacman, I'm going to say Pacman, then 2 colons, and then I'm going to say P, and load. Then I start with pacman itself. Then I start to list the packages that I want to load. So I'm going to start with one called Rio, and we have another one which is called TPLYR, and I have another one which is ggplot2. So you list as many packages as you want, and also you have this httr. Okay, then I run this command. All right, so it starts to install these packages. Okay, so it's installing. Make sure you're connected to the internet as it installs. So the next thing is graphics. Graphics in ARA. So ARA is a number of built-in tools for basic graph types such as histogram, scatterplots, bar charts, box plots, and much more. So we are going to explore these graph types as we go. So we are going to start with the plot function. We need to explore what this function is all about. Okay, so let's get into ARA and let's see how we can do about this. Okay, so let's start by calling data. So I'm going to say library, so that I call for the dataset package. Then I run this command, and I need the iris dataset. So this is the iris dataset, and I can zoom on that. And sorry. I can zoom on this, and we can see here that we have this dataset. So the dataset is too long. Let me try to get a brief of this dataset. So to get just a brief of it, maybe 6 variables. In ARA you need to type head, then you say iris. All right, then you run the command. So it gives a better view with very few data cases. It's no longer 150, but now I have 6 cases, which makes you just get an understanding of what we are talking about. All right, so now I need to do a plot about this for this data. So I want to start with the categorical variable. My categorical variable here is the species, so I can say plot. I want to use this plot. Then I say iris. In iris I need species, so now I can plot this one. As you can see, if I zoom on this, oh okay, I can't zoom because the other window has another graph. So what I can do here is, for me to zoom this, I need to write this command add. I need to create a new device new. Then right, so then I run this command, so it opens a new device. So this is where my graph should be. So I'm going to run this command, the plot command. So if I do this, and if I go and look for that device, I should be seeing my graph. All right, where is it? Okay, so this is the graph that the categorical graph, the graph for the categorical variable, the species. So it shows me that we have 50 for Setosa, Viscala 50, Virginica 50 cases. All right, so that's it for the categorical variable. I also need to do a plot for the continuous variable. So one of my continuous variables here is, let me just look at my data and see which one is a continuous variable. I think from what I'm seeing here is petal width. Petal width can qualify to be continuous variable, petal length and petal width. So let me work with petal width. So what I'm doing is I'm going to say plot, then I say iris, then petal width, and let's see, but I didn't put a new device. So let me start by putting a new device first. Let me run this, and then I click on this, so I should see my graph. So this one is, so by default it gives me this this plot. It shows the distribution of the petal width. All right, so that is for the continuous variable. I also need to understand the relationship between a continuous variable and a categorical variable. So I need a plot. So I'm going to say iris, then I put a $sign. I need species, and I need also iris. Now I need a continuous variable, and I'm going to use sepal width. I'm sure this can come out, and let's see the plot. Okay. Oh, I didn't put a new device. So I run this command, and I run the other command. Okay, so if I go and look for this graph, so that's the relationship between the species and the sepal width. So it gives me a box plot by default, which is very clear. So R chooses a suitable graph for this plot. All right, which makes it easier. And also I need to give a plot for two continuous variables. So I'm going to say plot, then I need iris, then I put a $. Before I do that, I'm forgetting one thing. I need a new device. So I'm going to say, I'm going to say def, then .new. So I run this command. It gives me the device number 7. So this is where my graph is going to be placed. So I'm going to say plot, and I need iris, I need petal length, I need petal width, iris, then petal width. Then also I can give specific instructions to R. Let's see, like color and title and labels. So I'm going to run this command like this. So I'm going to say color, and the color that I want my plot to be, I need a blue one, right? Then I put a comma, then shift enter, just to make my command not look too big. So I need to write it like this. So I can also say main. This is the title for the command, for the plot. So the title is comparison between petal length. So this is just a command, and width. This is just a title, sorry. Okay, so mind you, this is not a command, it's just a description of what I want as the title. Then I also write xlab. That means the label for the x variables for the petal length. So I'm going to label it petal length. Okay, then I need also the label for the y lab, the y variable. So I write this y lab, and I want it to be petal width. Then I run the command. Okay, so if I go and check the graph that I have, as you can see now, I've given ARA instructions, so it is let me zoom in on it. So it's basically showing me that as petal length increases, petal width also increases, which is logic. So I can also customize colors and also the title and the labels. All right, so that's it with these plots, and I think we are going to learn more as we go. We can also plot different graphs. For example, I can plot an exponential graph, which is plot exp. Then I can write the values that I want to plot it for. Right, so let me write 1 and 3, and let's see this plot. Oh, I forgot I need to have a device first. Then I run this command. Okay, so if I'm going to look for, okay, so that's how it is. I can also specify this plot and say I need color. So I'm going to say shift enter, so that I write this command. I'm going to say I need color to be red, and I need also I can put a title, but in this case I don't want to do that. I can also talk about the width of my graph. I want it to be 2 px. Then I run this command. Let's see the graph. Oh, okay, I didn't put again, I didn't put the device, the new device. Then I need my graph. So if I open device number 9, I'm going to see a new graph. Okay, so that's how it is in terms of plotting graphs. You just need to write the commands and you specify where you're getting your data. That's how it is. I think we are clear on this. So let me clear the console, and I also want to remove this. Next discussion under graphics is bar charts. So bar chart represent data in rectangular bars with the length of the bar proportional to the value of the variable, and we make use of the bar plot function in ARA. And let's jump into ARA and see how the bar plot function works, how we can plot bar charts. All right, so let's get into ARA. Okay, so now that we are in ARA and we want to create these bar charts, so we are going to make use of the data called empty cars. So I'm going to say library, as always the case, library, and then I call for datasets package. Then I run this command, and the data that I want to use today is empty cars. So empty cars, I run the command. So let me just say head empty cars, just get a brief of this empty cars data. All right, so this is empty cars. Let me zoom on it, and so it shows me that we have different cars with different cylinders, miles per gallon, horsepower, and etc. So these are the variables that we have, and those are the variables that we want to analyze. So let's start by creating a variable, or when we want to do a bar plot or bar chart, we don't just do it from the whole data set. We need to select categorical data. So our categorical data, in this case, I'm just going to look and see which one makes sense to be categorical data. So we can use cylinders. So we can use cylinders. So we can say cylinder is equal to, so we need to separate cylinder from the rest of the variables. Then we create a bar chart on it because it is a categorical data. So to do that, we need to create a table which is called cylinder, and the table is made up of empty cars and variable code CYL. Then we run this command, and we can now plot the bar chart. We can say bar plot, then we run cylinder. Okay, so this is the plot that we have now. This is the plot that we have. We can, for us to zoom on it, we need to create a new device. So I'm going to say device.new, and then I run this one. So this is the device where we want to place our graph. So I'm going to say run this command again, and let's look at the graph. So this is the graph, the bar plot. It shows that we have more cars with 8 cylinders than 6 and 4. So it just makes you understand the data you are working with. So that is it for the bar plot, for the bar charts. So we continue with our discussion on histogram, and now on graphics, and now we have histogram. So histogram deals with quantitative data, that is numeric rather than qualitative data. That's the difference between histogram and bar chart. Okay, so let's jump into R and let's see how we can do about histogram. All right, so I'm going to work with the data that is in R, that comes with R. So I'm going to call dataset package, right? Then I'm going to say I'm going to work with iris dataset. So this is the dataset that I'm working with. That's the dataset that I want to work with. So on iris dataset, I'm going to view iris dataset so that I see what is it about. So this is the dataset, the variables that are there, and for me to come up with a histogram, I need to select variables that are quantitative, that are continuous, and obviously species is no longer valid because it is a categorical variable. All right, so but the rest, sepal length, sepal width, petal length, petal width, they are all continuous variables. Okay, so I can now say hist, that's the command for histogram, and I can say iris, and on iris I need to plot a histogram of sepal length. All right, so I run this command. It's saying margin is too large. All right, so let me create a new device before that. So I'm going to say device.new, so that I create a bigger space for the graph. then new, then I run this. So I'm going to put my graph on this window on this device. So I'm now going to run this command, the yeast iris. I'm going to say yeast, then iris, and on iris I need sepal length. So let's try again and see. So it didn't put an error. So let's see if we have the graph. Okay, so this is the graph for sepal length. I can also plot another graph. I can say but I need the new device.new. Then I run this one. I have a device number 5, and I'm going to say yeast. I also have another continuous variables within iris, which is sepal width. Sepal width is also another continuous variable. And if I try to look for device number 5, I'm going to see that I have this graph. All right, so this is the graph that I have. And so I can do this for all the continuous variables. So now what I want to do is I want to compare these variables, these continuous variables. I want to try to plot different graphs on one window, one device. All right, let's see how we can do about this. So I'm going to say parameter, then mf row. But first of all, I need to create a device. I need to create a device. So let me just work with this one. I need to create a device first so that my graphs will be placed on that device. So I'm saying device.new. Then I have created device number 6. So I want to plot different graphs on this device. So to do that, I'm going to say then mf row, then I put C, then I'm saying I need 3 rows and 1 column. All right, so I run this command. So R now has created for me a device that is going to accommodate 3 different rows and 1 column. So I'm going to plot a graph yeast, and then that graph I'm going to use iris. Then I'm going to use petal length, and on petal length I want to say I need from iris species, I need to start to have I need to have a histogram of petal length, but for each species. So I'm going to first require setosa, right? So R should draw for me a histogram that is petal length only for setosa. Okay, so if I go here to my device number 6, I should see something happening. We have already a plot for setosa and petal length. All right, so let's see if we can have another plot. So for me not to waste time, I'm going to just go back to this command and change. I no longer want setosa. I need another species, which is Virginica. So these are the species that we have, Virginica. Then I just run this command, and also I need the last one, which is face color. That's another species that we have. So I should see these 3 graphs on one device. All right, okay, so now this is important for you to make different comparisons between these these three species. All right, so that's fine about this. So I think on histograms we have touched a lot of concepts on this, so we are done with this one. Let's move on. So let's continue our discussion under basic graphics, and number 4 is scatter plots. So scatter plots are the graphs that represent relationship between two variables in a data set, and scatter plots are all about relationships. So it's all about understanding relationships between variables. All right, what to note is scatter plots, they show linearity, spread, outliers, and correlation. So let's jump into R and let's understand the concept of scatter plots. All right. So in this scatter plots, I want to work with the data sets in R as always. So I'm saying library. I want to work with data sets. So I've coded for a dataset package so that I can access the data sets that are within R. So in this case, I'm working with empty cars. So let's just view empty cars. Or let me call for it first, empty cars. Then let me view empty cars so that we see what empty cars is for us. Okay, so empty cars, so it shows these variables that are there, just the cars and different variables, cylinders, miles per gallon, horsepower, etc, etc. All right, so now the next thing that we want to do is we need to see a relationship between two variables. So in this case, I'm going to do a plot for variable empty cars. I want to see the relationship between empty cars, the weight of the vehicle or the car, and empty cars and its horsepower. I want to see if there is a relationship, or is HP. So I want to see this plot. So it's saying, okay, let me create a device first. So it's device dot new. So my graphs are going to be on this device, and now let me run this command and see what we have. So that's the graph that we have. We have horsepower and we have weight. So we are saying, what are we saying? So we are saying generally the more the weight, the more the horsepower. So that's what it means. I can also plot, maybe I can give another plot. I need a new device, then new, then I have a device number 5. So I need to have a plot for empty cars. Then I need horsepower. Then I also need empty cars. I want to see the relationship between horsepower and no, let me not use horsepower, let me use weight and miles per gallon. Right, I can also customize this plot, because if I just run this command, I'm just going to get a default plot. So I can also customize it by saying we need color to be red, Then I also need to have plot character to be 12, right? And I also need the main as the title. Main, that's the command for the title, to be weight. Let me just say weight versus miles per gallon, right? Then I can also say I need my x. I need to x label, so I can just say x lab. Then the label for the x variable, which is the weight, let me just say wt, and then the y lab, that's for the label for the y-axis, so I'm saying it is miles per gallon, right? So I think we can have a graph, and let's see how it is if I run this command. Let's see if we can have our relationship. All right, so that's the relationship. We are saying the more we have weight, the more we have more weight, the less we have the miles per gallon, which makes sense. I think it makes sense, and we have our labels here, and we have our title. All right, so that is it for scatter plots. I'm sure you have understood. You have now an idea of how to run a scatter plot. All right. So continuing with our discussion on basic graphics, we are now on number 5, overlapping plots. So overlapping plots, these are plots that tends to give more detail than just an ordinary plot. So you see, you might have 2-3 plots on one graph. So this makes you rich in terms of the information that you are getting from the data. So let's get into R and see how we can do this, how we can generate overlapping plots. All right. So the first thing that I'm going to do is I'm going to say library. I need to use empty cars, which is a data which is within R. So I need to call first this data set package. Then I say empty cars, that's the data that I want to use, and empty cars is within R. All right. So if I say view, then empty cars. So what I'm going to do here is I need to see which graph I can plot here. So from this data I can plot a histogram of weight, and also I can also add on a normal distribution to see if how the distribution is if I use normal. So I'm going to plot a histogram and a normal distribution. All right, let's see. So the first thing I'm going to say is that's the code for plotting a histogram. But before that, I need to put a device where my graph will be. All right, so this device number 4, this is where I'll place my graph. All right, so I'm going to say east. Then I'm going to say empty cars, and I need weight, right? And I'm going to customize this graph. I'm going to say color, let me put purple. Then I don't want frequency, I need to work with density. Frequency is equals to false, right? Then I can also maybe put a title. So main, I'm going to say weight. I'm going to say weight. Right, so I can plot this graph. Okay, so we are going to see the graph. So this is the graph that we have, and we now need to add on a normal distribution to see how if this data was used for as to create a normal distribution, how would it be like. So let's see. So to add on a normal distribution, I'm going to say curve, then dnorm, that's the command, and x, then I'm going to say mean. Then the mean that I'm going to use is the mean of empty cars. Let me do this so that you see what we are doing. Okay, so the mean that I'm using is the mean of empty cars weight. That's the mean that I'll be using, and the standard deviation, ST, is the standard deviation of empty cars, and then weight, then I can do this. Then also what I need is we can talk about the width of the normal distribution. Maybe 2 it's okay. Then I also need to talk about the color of the normal distribution. I'll put it red, and I'll also, but before that, I think I didn't close this one. For the normal distribution, I need to close another bracket here. Then I'll specify the nature of the normal distribution after. So what remains is I think I'm done with this one. I think I'm done, but now I need also to tell R that please add this normal distribution on the data on empty cars weight. So it's true, empty cars weight histogram. So I want to add this curve. So let's see what comes out. If I run this command, I think I have an error. Where is the error? Where is the error? Let's see. All right. Okay, so I think I had placed 2 brackets here. So let's see how it will come out like. Wow, so that's the normal distribution added here. So we are saying if this data of weight, empty cars weight, was used to generate a normal distribution, it would come like this. So that's what we are simply saying. All right, I think on overlapping plots we have said something. We now have an idea of how to to really understand your data before you start to analyze it. All right. As we continue with basic statistics, we need to talk about describe function. So describe function quickly and easily describe data. That's the function of this describe function. So for us now to run this command or this function, we need to have one contributed package which is called psych, and we need to have it, like we have said, contributed packages. These are packages that need to be downloaded, installed, and loaded in R separately. So let's jump into R and let's make use of the describe function. All right. So in ARA, we are going to make use of the iris dataset. As always, we have been using this, is now very common. So I'm going to say datasets, then I'm going to say iris. All right, and also now I need to have my psych package installed, so I'm going to say from the introduction of this course, we have said we need to make use of the pacman. Pacman, if you don't have pacman, it's a package management tool that is used to load and install other packages. So it's a package that can store other packages. So if you don't have pacman, you can just say install packages, then you type pacman. Sorry, it's in the quotes, pacman, right? Then you run the command. I'm not going to run the command because I already have pacman installed in this machine. All right, so as you can see, I've already have this package. So now to make it available, it's already available in my machine, but just for you to understand it, I'm going to say pacman, and I'm going to use this package to install psych. So I'm going to say pload. So basically pacman is there to install and load other packages. So I'll start with pacman itself, pacman. Then we have agreed that describe function works with psych package. So this is the package that we need to install. So if I run this command, I'm going to install the psych package in the computer. All right, so but I also have this command installed in my machine, so I don't have any need to run this command. All right, so the next thing now is we need to describe. The describe function also works with quantitative variables. It doesn't work with qualitative or categorical variables. Okay, so let's see. I'm going to say describe. Remember, I have iris that I've called for, so I'm going to say iris. Then on iris, I need to describe sepal length. Then let's see if I run this command. So let me zoom on it. So these are the results. We are going to be shown the variables, the n, mean, so it gives a lot of information, the describe function, and also I can describe other variables, and you are only allowed to give description of these variables one by one. You can't describe them all at once, and so it just gives more information on each variable. All right, so this is it about the describe function, and this is how it works. It gives now that we have talked about basics graphics, and we have learned how to see visually the data, and now we have an idea of what this data looks like and what it is. So for us to keep on understanding the data, we need now to do some basic statistics. That includes the summary. So the summary, we use this summary function. So let's jump into ARA and see what the summary function tells us about our data. So the idea now is to understand our data so that we have an idea as we analyze it. All right, So like always, I'm using the variables, or I'm using the data set that is within R. So to use it, I'm going to call library. I'm going to call the data set package first for anything. Then the data that I'm using is iris, right? So now this is the data set that we have in iris. Now let me view it. Let me use the view function to view it. This is iris. All right, so this is the data. So when this data is like this, it's hard to tell what the properties of this data. So you need at least to have a summary so that you can really know what you are working with. So that's the importance of the summary function. So I'm going to say summary, then iris. So the results, here are the results. Let me zoom on that. Okay, so it's telling me that for each variable we have this mean, and we have maximum, minimum, and we have quartiles. So it specifies the variables, but I'm also allowed to say summary. Then I say iris, provided I just want to get a summary of petal length or any other variable. So it just picks that variable and tells you a summary of the variable. So for example, I can also say summary iris. So now doing these things, you get to understand the data that you have, and it's very easy now as you be analyzing it. All right, so that is it for the summary function. So now let's get to another important section where we want to learn how to enter data into R. So we are going to know that there are certain number of functions that are used when entering data into R. For example, we have colon operator, seek, and scan, and rep. So all these functions, they work when you want to enter data into R. So let's jump into R and see how this works. So we are going, so in R we are going to start by defining, or we're going to start by the colon operator. We are going to say X, and we are saying in X we need this data that we are now going to define to be into X. So we are starting from 0, then we use our colon to 10. So what we are saying, 0 to 10 should be in X. All right, so if we run this and if we ask for X, we are going to have this data shown here. So that means X has these numbers. All right, so we can also get these values using descending order. I'm going to say Y, then I use this and this arrow, and I'm saying from 12 to 2. So Y should be a variable with values from 12 to 2, right? So if I run this, I'm going to have 12 to 2 variable values. All right, so that is it with the colon operator. Now we need to see how the sequence work. We now need to see how it works. So I'm going to start with I'll use these brackets so that I don't need to repeat saying, if I say Y is equal to sequence then 10 or 12, so I don't need to if I put these brackets, that means I'm just right away I'll get the result. I don't need to put another y to call for y. All right, so if I just run this, I'm just going to get values from 1 to 12. All right, and also the sequence function works when we want this, let's say y1, and I'm going to say sequence. I'm going to say the sequence is, let me say 54, and 54 we want to use 54 to 0, and pi is equal to -2. So we want to move from 54 to 0 and using -2. So that's the data set. You have 54 up to 0, down to 0 in fact. So I have a spacing of -2 of 2 to 2 on these values. All right, so that's it with the sequence. And also we now need to learn another function, which is the concatenate or the combine, which is the C. So I'm going to say K, I'll use my brackets and say K is equal to C. So when I use C, I'll be allowed to give a list of values that I want to use. So I can just enter any value, and these values are being saved in K. All right, so if I call for K, or if I just run this command, because I have these brackets here, these brackets, automatically it will give me the values. All right, so you see now there's a list of the values that are within K. All right, so this is it for the C. And also we have another function which is called the scan. So I'm going to say ARA, I'll use ARA is equal to scan. Then I open brackets, then you hit enter. Now you are now allowed to enter the values. I'm going to say to call 21, then you hit enter. 3, 4, 6, 88, 34, 12. Then you hit enter twice. Right, so it has read 7 items. If I call for R, I'm going to get the 7 items. All right, so these are the values that I have now. So that's how the scan function works. The C function works. That's the concatenate or the combine, the sequence, and the colon operator. All right, so we also have another function, which is the repeat function or the repetition function. All right, so I'm going to say, for example, if I have a scenario where I'm going to say X, and I want to repeat certain character or certain values a certain number of times. So I'm going to say repeat, then I want T, a character code T, to be repeated. I want it to be repeated 34 times. I don't want to keep typing T. So if I just put this, it should give me the T repeated 34 times. So that's another way of entering data into R. So we have learned a quite number of methods. It now depends with the one that you want or you feel you can make use of. All right. Another interesting thing about ARA is we can import data from other packages, that is from Excel and Starter, SPSS, or those packages. All right, so let's jump into R and see how we can import data from Excel. All right, so we are going to get into R, and I'm going to illustrate the first method. And the first method is I'm going to use a command, the command method. So I'm going to type my command here, and I'm going to, but the first thing you need to consider is your Excel file. Is it in CSV or another format? If it is in CSV format, separated values, you need to call for a package which is called so like when I say library, I'm calling a package which is called the package is called read R. So that's the package that I use, or that is used by R for CSV files. So I've called for this package. It's now available. It's now loaded in my R. So the next step now is for you to call for the data or import the data. So I'm going to label the data, right? So then I'll say read, then underscore CSV. Then now I need now to get the address of the data. So you need to go to where your data is. So in my case, my data is located on my desktop, and it's over here, written Baobab. So I'm just going to copy path, right? And once I copy path, I'm going back to R and I'm going to paste. But mind you, in R, we need to change these slashes to, they should face the other side. All right, just change those only, and the rest, they remain the same, right? Then you say, you run the command. So once I run the command, already my environment is saying something, saying we have 115 observations of 15 variables. All right, so let's view this data. Let's view this data. So I'm going to say view data. Then I run this command. Okay, so let's see. So this is the data that I've coded for. That's my data over here. That's a lot of data. All right, so now that I've done this, and also I want you to know the other method of importing data. You use the graphical user interface on file, and you go to import. Now it's all about clicking, and I have a CSV file, so use read R. If you have another format of Excel, use Excel. If it is from SPSS, from Starters, SAS, so it depends with the way your data is. All right, so I'm going to say read R. Then I'm going to browse, and I'm going to locate my data set. Where is my data set? And this is my data set, and I'm going to open, and I'm going to, oh, it's already reviewing. You have the option to see the data. All right, so you can import now. So it gives the same results, and it's now written Baobab. The first one was data. So that's another method of importing data from Excel. All right. Another important section in R is the principal components. So principal components as analysis is concerned with explaining the variance covariance structure of a set of variables through a few linear combination of these variables. So the general objectives is data reduction and interpretation. So we are trying to reduce the number of variables and still explain much of the data. All right, so the steps in PCA is you need to first check if the data is suitable for principal component. Building correlation matrix to check for linear dependence. All right, so once that is passed, or then once you see that there is linear dependence and you have seen that your data is eligible for principal component, now you start developing the principal component analysis. Now you're building the model, and model evaluation, the model that you have built, you need to evaluate it, checking the loading matrix, correlation matrix of the principal components. All right, so that's it with principal component. For us to get a bit together, the rest of the principal components, for us to understand what it is really, we need to jump into ARA and let's just do some few analysis. All right, so in ARA, I'm going to work with dataset that is within ARA. So the first thing that we need to do is to have our tools, our packages that we want to use in the process. So like I encourage, or I advise, for you to install a package in ARA, you need to work with the pacman, the package management. So the package management allows you to install other packages. It's a package that allows you to store other package. So I'm going to use pacman. So if you don't have pacman, you need to install pacman install dot packages. Then you put these codes and you type pacman. So pacman, once you run this command, control enter, and you run this command, pacman will be installed. But I will not do that today because I have pacman installed in my machine. All right, so I'm going to leave this command, but if you don't have it, please just run this command. All right, the next stage is now for us to install or load other packages. So I'm going to say pacman, then double colon, and I'll say p load. So that's the command for you to load other packages using pacman. So you start with pacman itself, and now you list the packages that you want to install or to load. So in our case, we need states. That's one package that we need for principal component that is going to help us develop a script load and develop other correlation matrix and to do the correlation tests. All right, so we also need is it dyplr. We need this package. All right, so these are the packages that we are going to work with during this session. All right, so now the next stage, now what we need to do is to identify the data that I want to use. I'm not going to run this command as well because I have this loaded in my machine. All right, so now the next thing that we need to do is to make sure that we have the data set that we want to use during the process. So I'm going to make use of iris data, maybe for you to familiarize with iris. I'm going to say first, I'm going to say library. I need the dataset package. Then I run this, and I'm going to need, let me view the iris. That's the one that I'm using, the iris dataset. All right, this is the dataset that is loaded within ARA. It comes within ARA, so that's why I've called for the datasets package, because I need a package that is within ARA. All right, so when I run this command, I'm going to get this dataset, and this is the data set that I want to use for my principal component. But obviously species, I won't need this during my analysis, so I'm going to create a new data set. I'm going to call it DTA, and I'll say select. I want to remove that species. Select, so I'll just want to remove the whole column. I don't need it. So select, I am going to select from iris. I'm selecting what am I selecting? The number of columns that I want. Oh no, the types of columns. I need column 1, column 2, column 3, column 4. So column 5 is the species, which is the one that I don't want. So I'm going to run this command, Control Enter. Right, if I want to view the DTA, my new data set, I'm going to say DTA and run this command. So this is the command that follows. So this is the data that I want to do my PCA. All right, but now what we have understood about principal component, we have agreed that we need to check whether the data is eligible for PCA. So how do we do it? We need to do correlation. So we are going to say correlate my DTA. Right, we need to see if this is possible. For us now to see it, we also need to get a mean of the correlation. So if the mean of the correlation of these variables is greater than 0.3 or greater than negative 0.3, that means that data set is eligible for principal component. So I'm going to say call DTA, then I run. All right, so this is 0.46, which is greater than 0.3, and that makes this data suitable for principal component. All right, so the next stage now that I have agreed that this is suitable for principal component is now to build the model. Let's build the principal component model, and we'll do further analysis on it. So to do it, I'm going to label principal component analysis. Then I want to say run this command, printcom. That's the command that I'm using for my principal component, and printcom DTA. So now I'm using my new data set, which does not include species. All right, so that's my printcom. The results are being loaded in PCA. All right, so now we need to evaluate the PCA, that the model that we have built. So how do we do it? The way we do it is we are going to ask for loadings. So I'm going to say PCA, and then I need some loadings. All right, then I run this. Okay, so when we are assessing this model, we want to make sure, or we just want to check whether the PC, or the principal components, captures the essence of the original variable. That is what is important. Are we capturing the essence of the original variable? As you can see, we have four components, and we also have 4 variables. That means we are capturing the essence of the original variable. That makes it a good model, or a good principal component. All right. So it shows also the weights. It shows that petal length is high correlation with component 1, and that means I can use component 1 to even explain petal length, because there's a high correlation, as well as component 2 is a high correlation with sepal length and sepal width. That means component 2 can explain much of petal sepal length and sepal width. All right, so that's how it is. That's how it is with these principal components. All right, the next thing is I also want to check whether the PCs are independent. So to check whether the PCs are independent, they should have a 0 or close to a 0 correlation. All right, so to do it, I'm going to say principal component, principal PCA, my PCA, and then I ask for scores. All right, I want to check this, then I run this command. All right, I can view, let me view this, let me label this. Okay, let me label this PC. This is equal to this, then I run this command and I can view PC, view PC. I run this command. So I have four components. These are the 4 components, but I want to see if there is if there is independent between these components. All right, so to do it, I'm just going to say correlation, then PC, and we have agreed that for me to know that these components are independent, we need to have correlation which is close to 0 or even 0 itself. All right, so as you can see, we have this is the correlation, and if you can see here, we have a correlation of negative 2.8 times 10 to the power negative 16. That's a lot of zeros, and that is very close to 0, and this makes it the PCs, this makes us agree that the PCs are independent. Also, we can do some plots. We need to plot a script plot, then I'm just writing plot, then PCA. All right, so let's run this and see what we have. Okay, so this is what we have. It shows, let me try to create, okay, let me create a new device so that we can see clearly. I'm going to say div, then new. This is a script plot, and then let me run this. Then I'm going to plot, but I want this to be a line graph, so the type should be equal to line. Then I run this command and I view. All right, okay, so this shows that component 1 has much importance than the rest of the components, and that means even if I work with component 1, I still get the significance of the model. So, but we in principal component, we look at the elbow. That's where we decide the number of components to keep. So I would say if I keep component 2, is still okay, it's making sense. Or even component 3, I can work with 3 components and still get much information from the data. All right, so that's it. And also I can get a summary of PCA to get the importance of these components. All right, importance of components. That means, as you can see from this, it means that component 1 explains 92% of this data. So component 1 has a lot of weight than the rest of the components, and the cumulative proportion, if I take component 2 and explains, if I take two components, the cumulative proportion, it explains 97% of the data. Then it's making sense. I don't need to, if I have, if I can explain 97% of the data, to me it makes more sense, and I don't even need to have the whole of the data. So that's data reduction and ease interpretation. That's the work of principal component. Even component 3, 99%, already it's making sense. I can work with 3 components and still get rid of what I want to analyze, or get an understanding of what this data is all about. All right, so that's it. That's principal components. That's principal component. All right. So another important concept in R is to know how to do regression. So regression is a statistical technique that relates a dependent variable to one or more independent variables. So regression is all about relationships between variables. Okay, so let's jump into R and let's start regression in R. So in R, we need to have certain packages for us to do regression, just like our other concepts. If you want to do anything in R, you need to first make sure if you have the package available for such operation. So for regression, we are going to use certain packages, but like what we have discussed before, we need to have the Pacman management tool, or the Pacman package, which is a package that enables you to install or load other packages. It just helps. It's easier to work with Pacman when you are installing or when you are loading other packages. I'm not saying it's not possible to do without Pacman, but it is just easier because you can load as many as packages you want at once. All right, so let's make sure that we have installed Pacman. So to install Pacman, you just need to write this command, then Pacman. All right, so that's how you install Pacman, but I'm not going to run this command because I have Pacman installed already. As you can see here, it's already installed, and the next thing is now for me to use Pacman to install other packages which are important during this session of regression. So I'm going to say Pacman, then double colon, and pload. Then I'll start by loading Pacman itself. And also now I can list as many as packages I want. So the first package that I want is caret. That's the first package, and the next package is las. So basically I'm just going to work with these two packages during the process. All right, so now these packages are installing. I'm just going to wait a bit as they install. All right, I hope they won't take long. They're downloading. Okay, so now I have my two packages installed, including Pacman, and they are also loaded at the same time. So the next thing now I need to do is I need to have data now for me to operate my regression. So the data that I'm going to use is data that is already in ARA, but for me to access that data, I need a certain package which is called datasets. So I need to call for this datasets package. So I'm going to say library. That's the way we call the packages. So I'm going to say datasets. Then I run this command, and I'm going to say which dataset am I using. I want to use empty cars. Let me just view empty cars. View empty cars. Then I run the command. So this is empty cars. This is the data that I want to use, dataset that I want to use for my regression. But what am I regressing? What I'm doing here is I want to see what's the relationship between horsepower and the rest of the variables that are here. So, but for me to achieve that, I need to separate horsepower from the rest of the variables, and I create a new dataset and I call it another name, and I label it. I give it the other variables except horsepower, and also I create another horsepower variable or dataset. Then I compare the two datasets. All right. So to achieve that, I need just to know which the number of column, the column number for HP, which is number 4. So I'm going to say the new data set, I'm going to call it X. I'm saying X is equal to as matrix. I'm treating it as matrix. Then I label where it is coming from. It's empty cars. Then from empty cars, I want to remove column number 4, right? Then I view to see if I achieve this. I view X. All right, as you can see now, we have removed HP, which is important. And now the next thing is we need to have another data set, which is called Y. And I'm saying Y is equal now to empty cars. And from empty cars, I'm taking column number 4, right? So I run the command. And once I do this, I'm going to say I need to see what if we have achieved what we need. Let's see if we have achieved that already. I'm going to say view Y, and I run the command. I think we have achieved it. We have 32 and we have these values. So I think we are done with that. We have finally separated them. So now we now run the regression. So to run the regression, I'm going to say I will label the regression model REG. Then I'm saying LM, and I'm saying I want this Y. I want to see the relationship between Y and X, the rest of the variables. Then I run this. Now for me to get the results, I need just to say summary of REG, the model. Then I run this. So I'm going to see the coefficients listed here, and the standard error, the t-value, the probabilities here, and the significant codes. And also one important thing is the multiple R squared, which is 90%, and adjusted R squared 85%, which makes this model a good fit of the data, as it explains 90% which is a very big, very large number. And now I'm also going to do some other commands. I'm also going to say I need to see the residuals. So the residuals, I'm going to say resid, then reg, then I run the command. So these are the list of the residuals that are there, and for me to visualize them in a proper way, I need to have a histogram. So I'm going to say hist. Then when I say hist, I'll start to give the type of graph that I want and from which variable. So I need from residuals of reg model. Then I run this command. Now you can see we have this this histogram. I can also specify, it's also allowed for me to specify the color to be blue, any color of my choice, but I'll work with blue. I can also, I want also to remove the frequency and put density. So I'm going to say frequency is equal to false, right? I think that's okay. Then I can run this, and also I want to add a new plot that is a normal distribution. I want to see if this data was used to create a normal distribution plot. What are we supposed to get? So we need to understand this. So to add another plot, an overlapping plot, we are going to say curve. This is for a normal distribution, t-norm. And I'm going to say x, then mean. For the mean, I'm going to use the mean of the residual. Sorry, it's resid. Then from the model reg. Then also I need the standard deviation, and it's coming from the resid reg, right? Then I'm going to put a comma here, right? So I'm also going to customize this normal distribution. Color, I'm going to put red, and I'm also going to put the thickness of the graph. I'm going to put 3. Then I'm also going to say add, which means I need it to be included on the histogram, this histogram, and I'm going to say add. That's true, right? Then I run the command. So now you can see this is the graph that we have produced. So it shows that the residuals, they are normally distributed and they are skewed. So this is how it is with regression. So you can also do other functions. You can, if you are not sure, you can also ask names, and you write the model. It gives you the number of variables or the number of functions that can be found from this model. So it now depends with what you want to study or what you want to know.